Did you hear it? What you just heard are two supermassive black holes colliding with each other, ripping up space all around them with their gravity. With both black holes about 30 times the mass of our sun, this collision released 50 times more energy than every star in the observable universe. Black holes are easily one of the most well-known space objects in the universe for a good reason. They're very mysterious. Nobody knows what happens when a black hole absorbs something. All that's known is that nothing comes out. Despite how ominous and dangerous they may seem, the universe is riddled with them, with new ones being born even to this day. If our sun, with a diameter of 865,000 miles or 1.4 million kilometers, and a mass of 2 times 10 to the 30th power kilograms, collapsed into a black hole, what would happen? Well, for starters, the mass of the now black hole would be equal to what the mass of the sun was. For the diameter, however, it would be different. The diameter of the black hole would be about 3.7 miles, or 6 kilometers. This is about 1.4 miles wider than the diameter of Manhattan Island. Now, if the Earth were to collapse into a black hole, it would be about the size of a grape, or about 9 millimeters. Sagittarius A*, famously known for being the supermassive black hole at the center of our galaxy, is the closest supermassive black hole. The black hole itself is about 17 times wider than the sun's diameter. If it were to replace our sun, it would eventually absorb every planet within our solar system. Alongside being the closest supermassive black hole, this is also one of the only two black holes that have ever been imaged using the Event Horizon telescope. Although the image of the black hole may not look like much, the Event Horizon is clearly visible within this picture. An event horizon is the part of the black hole where gravity is so strong to the point where not even light can escape from it, hence giving the black hole its name. Next up is the M87 black hole, the first ever imaged black hole. Very similarly to Sagittarius A*, this is also a supermassive black hole at the center of a galaxy called Messier 87. This black hole, however, is a whopping 1,000 times larger than Sagittarius A*, and if we were to put this black hole within our solar system, the event horizon would engulf everything past Pluto. With monsters this big, light is the only thing that is able to reveal these things from the vast darkness of space, only for light itself to not be able to escape. To put everything into perspective, light travels at 671 million miles per hour, or nearly 300 million meters per second. Yet, the black hole's gravity is so strong that even light cannot escape from it. When the first image was taken, a Hawaiian language professor decided to name the black hole Povehi, meaning the adorned, fathomless dark creation. In 1957, the Tonacintla Observatory marked a faint blue star in the night sky. 13 years later, in 1970, a radio survey was conducted in Italy discovering radio emissions from the blue star. This discovery led to the blue star to actually be classified as a quasar. The quasar itself wasn't particularly named, rather its name was derived from the catalog of the observatory that first discovered it. Ton 618. This black hole is so massive that it puts M87 to shame. Ton 618 is approximately 16,000 times larger than Sagittarius A*. This makes it the largest black hole that has been discovered to date. Now, keep in mind when I say discovered, because we have discovered literally nothing in the universe so far. Ton 618 is around 10 billion light years away, which is incredibly far, yet it doesn't matter because the beast radiates 140 trillion times more energy than our sun, making it a beacon within space. For all we know, the black hole is even larger than how we are observing it right now, because what we are seeing is how the black hole was 10 billion years ago. For all we know, there could be a black hole located in the Milky Way that's even larger than Ton 618. We just have no way of knowing at the current moment. Now, the most distant object that we have discovered is a galaxy that is about 13.4 billion light years away from us, making it around 3 billion light years further than Ton 618. This goes to show how even in the early universe, a black hole this big was able to form. Recent studies have shown that a black hole known as Phoenix A, located in the Phoenix galaxy cluster, might actually be larger than Ton 618. Phoenix A carries a mass of 100 billion times that of our Sun, while Ton 618 is only 66 billion times that of our Sun. None of this is confirmed, however, leaving Ton 618 as the current king of the black holes. In the movie Interstellar, the setting of the story takes place in a solar system around a supermassive black hole named Gargantua. Now, although the movie is science fiction, most features within the movie are scientifically possible. The producer of the movie, Christopher Nolan, worked with theoretical physicist Kip Thorne in order to ensure that all the calculations within the movie were accurate, including the black hole. In the movie, we learn that if the team land on Miller's planet, the team would perceive time differently compared to everything else. One quick fact is that anything without a mass will travel at the speed of light. This includes light and gravity. Now, us humans, we don't really know what time is. However, we do know that the greater the gravity, the slower the time will pass. This phenomenon is known as time dilation, and it is one of the most fascinating things in the universe. Since time is part of the fourth dimension, gravity warping space would also result in time also being warped. The reason that time is different on Miller's planet is because of Gargantua. The planet is so close to the black hole that the gravity of the black hole warps the space-time around the planet, causing time to slow down. Taking all this information into account, we can recognize that the closer you are to the singularity of a black hole, the more time slows down all around you, and this will continue infinitely. Nobody really knows what happens at the center of a black hole, as all physics breaks down once you reach the singularity. Some theories suggest that black holes lead to different universes, acting as a wormhole between universes. Even if these theories are true, there is no possible way that we can gather this information in order to prove them. Now, in my opinion, what the scariest thing about a black hole is that anything is able to turn into a black hole. The reason we don't see any tiny black holes is because stars are the easiest thing in the universe to become them. The way that black holes are formed is when an object's mass is compressed to the Schwarzschild radius. The radius acts as a boundary, and once that boundary is passed, light can no longer escape due to the gravity. Now, why haven't we found any black holes closer to us? Well, if we remember earlier in the video, if the Earth was compressed into a black hole, it would be the size of a grape. If we did this with any object that we had in our kitchen, let's say, the black hole would become microscopic to the point where we wouldn't even be affected by it. A spoon, for example, would turn into a black hole smaller than an atom. If you're wondering how small that is, well, take a strand of your hair. Now, an atom is something about 1,000,000 times smaller than the strand. To put all of this into perspective, the human body contains around 7 octillion atoms, which is a 7 with 27 zeros after it. All this information means that we could theoretically be breathing in black holes as we speak, but obviously, it doesn't affect us. All of this is theoretically possible, however, there hasn't been any proof of any of it yet. That's all I got for the current moment. There's tons more to talk about, however, I myself still don't know that information. Let me know what you guys think about the video, what I should do to improve, and what I should talk about next time. I'll be reading the comments, so make sure you let me know. Thank you for watching.